How's it going, guys? Today in this video, we're going to be going over Module 16.3, Day 2. It's going to be very similar to 16.3, Day 1, solving logarithmic equations, but we're just going to have word problems. So just giving you the equation. So let's go ahead and just start the problem. On number 1, we're told the energy released by an earthquake can be a very large number. So a much smaller number is reported as the magnitude of the earthquake. The magnitude M of an earthquake with energy E in ergs is calculated using the formula M equals 2/3 log E minus 2.9. And we're told the largest earthquake known to have occurred in Texas happened August 16, 1931, and had a magnitude of 5.8. So we know M equals 5.8. And we want to know how much energy did the earthquake have. So to do this, what we're going to do is just plug in M plug in 5.8 for M, and we're just going to solve the problem. So we have 5.8 equals 2/3 log of big E minus 2.9. We'll add 2.9 to both sides to get 8.7 equals 2/3 log of E. And then we're going to multiply both sides by 3/2 to cancel out that 2/3 on the right side. So these cancel out, and we're left with 13.05 equals log of E. And then from here, we're going to change it from a logarithmic equation to an exponential. And remember, if you don't see a base on a log, that just means it's the common log. So it's a base of 10. So this is going to become 10 to the 13.05 equals E. And that's where we're going to leave it, just like that. All right, let's go on to number 2. On number 2, we're going to be using the same equation. M equals 2/3 log base E minus 2.9. And in this problem, we're told an earthquake that occurred on December 7, 2013, near Volcano, Hawaii, had a magnitude of 2.9. So our M is 2.9. And we're asked how much energy did the earthquake have. So we're solving for E, same thing. We'll plug in 2.9 for M, and we're going to solve for E. 2/3 log of E minus 2.9. So we'll add 2.9. We need to isolate the logarithmic equation, a logarithmic function. So add the 2.9 to both sides to give us 5.8 equals 2/3 log of E. And then from here, we're going to multiply both sides by 3/2. These cancel, and we have 8.7. All right, and 8.7 is going to equal log of E. Now we're going to change it from a logarithmic equation to an exponential. So we get 10, 8.7 equals E. And that's going to be our answer for number 2. So let's go on to number 3. On number 3, we're told the difference between the apparent magnitude or brightness M of a star or little m of a star and its absolute magnitude big M is given by the formula little m minus big M equals 5 log of D/10, where D is the distance of the star from Earth. Measured in, I think it's pronounced parsecs, the star's Antares has an apparent magnitude of 1.0, so little m equals 1.0, and an absolute magnitude of negative 5.3. So big M is negative 5.3. And we want to find the distance, or D, of Antares from Earth. So we're trying to find D, and we're given little m and big M. So we're going to plug in both these variables into the equation, and we're going to solve for D. So we have 1.0 minus negative 5.3 equals 5 log of D/10. So 1.0 minus negative 5.3 is a positive 6.3. That equals 5 log of D/10. Then we're going to divide by 5 on both sides to get rid of that 5 on the right side and to isolate the log. And 6.3 divided by 5 is 1.26. That'll equal log of d over 10. And now we're going to change it from a log to an exponential. So we get 10 to the 1.26 equals d over 10. Then we'll multiply by 10 on both sides to get 10 times 10 to the 1.26 equals d. And since both of these have the same base, we can add the exponents together. So we have 10 to the 1 times 10 to the 1.26. We can add them together to get 10 to the 2.26 equals d. And that's going to be our answer. All right, and that's it for the video, guys, and hopefully it helped.